Great. Hi, welcome. This is Train the Admin, and I'm Sarah Edwards, and this is Josh Smift. Josh could turn around his face. Okay. Okay, and great. And so let's go ahead and get started. We're obviously starting late. Just a second. So we'll try to keep this as tight as possible. All right, so we have a lot of topics. This is sort of like the first 5 or 10 minutes of a large number of little topics that are useful if you have a rack or you're in some sort of operation somewhere in the GENI Federation. And so I'm not even going to go through the outline. Let's just get started. Okay, so the first thing is this is sort of a side note, but if you're there's a couple of small technical issues that people run into when they use GENI in the classroom, which is something of interest to a lot of campus IT. So I'm just going to knock those out of the way real quick, and then we'll talk about other stuff. So there's 4 areas if you are a rack admin and you are involved with campus IT where you can help. They are, number 1, students, it's really helpful for classrooms or researchers to be able to access, to log in using the GENI portal, and to do so using InCommon. While obviously you can get an account through the GENI project identity provider for a large class of students, it's really helpful to get in through InCommon. And which in InCommon is this federation of research institutions which sort of supports this single sign-on, which GENI supports. So it allows people to log in with their existing usernames and passwords issued by their own institution. And so if you are campus IT, you can help us out. And so basically the GENI portal gives access to real resources, and so we need to be able to contact experimenters if something goes wrong. And so we require the EPPN and the email address of the user in order to access GENI, and we like to receive their affiliation, given name and surname. And it's actually really easy to turn this on. There's a research and scholarship category in InCommon that you can just sort of like check a box and enable that. And if you haven't already figured this out, which I'd be shocked if you hadn't, you can go try logging in. Just go to portal.geni.net, try to see if your institution's on the list. If it is, you can try logging in. And if that doesn't work, you can send mail to portalhelp@geni.net, or if you have trouble remembering that, just help@geni.net, and we'll get you pointed in the right direction. Yeah, no, it's shibboleth based. That's the whole point, right? So the whole point is that you have existing accounts at your school, and yeah, exactly. But you have to be a member of InCommon, and you have to enable this research and scholarship category, or release the equivalent attributes. The second thing that comes up in classroom use of GENI is SSH for Windows. We use SSH key pairs, SSH with a private key, and doing that from Windows is a bit of a pain. And there's a large number of possible solutions, which is to say none of them are good. And so if your campus has a standard solution, that's something to discuss with your professors to make sure things are good. The third thing is there's client tools that you use on GENI. If you've been to any of the tutorials, which I believe most of you have, there's Omni, which and then there's things like FLAC. And basically, if somebody's using this in a class, you might think about how the professor should be thinking about how their students will access things. Are they using their own laptop? Are they using a lab computer? Is there a VM with a software loaded? And in the lab computer case, you need to make sure that that the software is accessible. And then finally, something that comes up a lot, especially on, GENI is this highly distributed system with lots of services running on some unusual ports. And periodically, strange things get blocked in weird ways. And even legitimate GENI traffic sometimes get blocked. In particular, campus guest Wi-Fi networks. Campus guest Wi-Fi networks are frequently a problem. In fact, I think I've never met one that wasn't a problem, although maybe here is the exception. And so we publish this list of known GENI ports. So it's useful to check that list against things that your campus might block to make sure that GENI is accessible from your campus. So that's, and then one last thing. When we talk to instructors and we do train the TA, we have this sort of timeline and checklist for when they should do certain things and say, basically first you should figure out how people are going to log in, and then, they should notify GMOC and things like that. And so there's this checklist, and if that's useful to you, you can check that out. Okay, good. All right, so that was just sort of things that are of use for using GENI in the classroom, and perhaps people in the room might find that useful because they're sort of the same audience. And the rest of this is about sort of various aspects of administering GENI itself. So the first basic question is, who can access a GENI rack, or who can use a GENI rack, right? So the general answer is that users have to have an account from one of three places: the GENI portal clearinghouse, which is becoming the most common and is what we use at GEC. You can also access it via Emulab and Planet Lab. The thing that is common about all three of these cases is that somebody's been vouched for in order to access GENI resources the first time, right? The mechanism is a little different in each case, but in order to access resources, somebody has said, yeah, I'm okay with this person and, using this. And then, and also in all three cases, there's somebody who is responsible for creating those accounts, who you can contact if you need to get in touch with an experimenter if there's a problem, right? So that's sort of the basic thing. Then, just to be a little more concrete about it, so GENI users come in, they have a tool, right? And they speak to a clearinghouse or the GENI portal, right? And they, that's how they get their user accounts, and that's how they get their slice, right? So they get a slice credential back, and they pass that slice credential to an aggregate manager. And that's how they reserve resources, find out the status of their resources, right? And so, like I said, there's these three different flavors of places where you can get an account and slices, the GENI portal, Planet Lab, and various parts of the Protogenie Emulab Federation. And in addition, there's lots of different kinds of aggregates. There's GENI racks, there's Internet 2 stuff, Emulab, Planet Lab, foam, all those sort of things. Okay. So to be a little more specific, in the case of the GENI portal and clearinghouse, which is the accounts that we're using here, I just want to talk a little bit more detail about how experimenters get access to things, right? So the clearinghouse is a set of services that tracks experimenters, that's basically user accounts, projects, slices, and also has an authorization service. And then the portal is this front end for that clearinghouse. So it's a web-based interface to that. And the distinction here is that even if you're using Omni, for instance, you're still talking to the clearinghouse, but in that case, you're not talking to the portal. And basically, anyone can get an account, but you can't do anything interesting unless you're a member of a project. So for the GENI portal and the clearinghouse, that aspect of experimenters can't, somebody has to vouch for an experimenter. That happens when you join a project. The project lead shouldn't allow you to join a project unless unless they know that person and they're willing to work with them. Okay. So right. So then this sort of all hangs on how do you become a project lead, right? Because now we're trusting project leads to make a decision about experimenters. So as you remember, projects, or if you've done the intro sequence, projects are sort of how we organize research. It contains both people and their experiments, right? So we have this project lead who's a single responsible individual. He can add other people to his project, and once people are in their project, they can create slices to run their experiments. Right now, by policy, in order to be a project lead, you have to be a professor, some sort of academic faculty, or a senior member of a technical staff if you're in a non-academic environment. And it's possible to have an exception made, but those are the two things that we sort of approval process there is sort of a well-oiled machine. So if you get this project lead bit, that allows you to create projects, not just one project, you can create multiple other projects. And what that means is that a combination of this in-common IDP user account business is combined with this means that we can contact both the experimenter and the project lead if something goes wrong. And we, on occasion, do that, not real often, but it does definitely happen. Right, so we have this ability to contact sort of multiple relevant parties if there's an issue. And in particular, in the case of the portal and clearinghouse, this is actually pretty baked in. So slices are identified identified uniquely by a combination of a URN and a UUID. And the URN includes not just the slice name at the end, but the issuing authority. And in the case of the portal, it includes, or the portal and clearinghouse, it includes the sub-authority, which is the project name. So we are tying in, it's not just that you're a member of this slice, but you're also a member of this project. That's sort of tied in pretty fundamentally into how those particular accounts work. And then, and likewise, just by looking at like a user URN, you can not just see the username, but you know who issued what authority issued that URN, right? So these are sort of the identifiers that are in certs and things that are shared throughout, certs and creds that are shared throughout the Federation. All right, so that's who can get accounts. And then the question is, what are they getting access to? So there's two different kinds of racks. We have InstaGENI and EXOGENI racks, sort of starting west and going east. InstaGENI racks are built by the folks at University of Utah. There's a rack and Rob Ritchie and Lee Stoller. And they're built from HP hardware. And then the EXOGENI racks are built by the folks at Renzi in North Carolina. And they're using hardware from IBM. And there's an EXOGENI rack. And the dots are all the places where there either are or going to be racks, and I believe there are racks in progress at basically all of those dots. Right, and so then what is a GENI rack? People talk a lot about GENI racks, but we don't really narrow it down real often. So a GENI rack contains both compute resources and an OpenFlow data plane switch, and it speaks to the AM API. I'm pretty sure that anything that satisfies those three requirements would be considered a rack. It's also obviously in a physical rack. And those racks are connected across the they're put in a campus. That campus pipes things across a regional and then through a backbone provider. And I already said who the two teams were. Oh, and in addition, there's two other flavors of GENI racks being worked on. There's a Dell version, which is a prototype. I said a prototype. Actually, I think it may be deployed, and I'm not sure if it's production yet. Is the Clemson rack? The Clemson rack is made by Dell, is really close to being a real thing. And the Cisco one, I think is it? Yes, maybe you can hear. I do not. I'm so sorry. But we can probably find that out. Okay, and good. And while this talk is not about how to get a GENI rack, I figure there might be people in the room who might be interested. Basically, if you're interested in getting one, you email help@geni.net. There's obviously, there has to be funding from somewhere, and SF has purchased many of them. In addition, there's a couple of checklists. There's a high-level checklist of things that are needed in order to get a rack from a delivery to production release. And there's at least for InstaGENI, there's a rack requirements checklist. I'm not sure if there's an equivalent for EXOGENI. And you can go, there's a wiki page that lists all the production GENI aggregates. And in order to be listed on that page, you have to have been tested out and released for production. And there's a small number of dev racks, which are production racks, but where the software may change with and or may be a little bit buggy, because that's where people deploy and test new software. All right. Good. And so what do these two racks look like? So again, apparently I'm going west to east on my racks today. So an InstaGENI rack is, again, just a rack. The picture on the left is the front and the right is the rear. And so at the top, there's a control plane switch, which is how you connect out to the internet, and it connects to each of the individual compute nodes and resources on the device through the control plane. There's a datapath switch, which is an OpenFlow switch, and that's how and that connects the data plane between all the compute nodes and the outside world. There's a control node which runs 4 VMs. The VMs are BOSS, Ops, Foam, and Flowvisor. That's sort of the brains of the operation. And then there's 5 experimental nodes, or it says experiment nodes, but those are the compute nodes that you have access to when you reserve resources. And then the InstaGENI racks have a large amount of air, if you will, which is meant to be empty spaces where you can expand and add new features. And also, I think there might be some power supply PDUs in there. Right, so that's sort of the pieces of an InstaGENI rack. Then for EXOGENI, it's sort of similar but different in some key ways. So again, front is on the left and back is on the right. And so again, they have a control plane switch and an OpenFlow data plane switch. Then there's a VPN box so that the EXOGENI folks can get in and manipulate the rack. There's an iSCSI storage. You'll notice that's something that the InstaGENI racks don't have. Then there's these 10 worker nodes, which are the compute nodes, the resources that you get when you reserve things. And then there's a console, and there's a head node, which is basically the control node, and that's the brains of the operation for the EXOGENI rack. Good. And so that's what an EXOGENI rack sort of looks like. So there's a little bit, I have I guess this is, maybe I have 1 slide, 2 slides on some hardware specs. So you may have noticed that there's, the 1 controller head node in each rack, and then 5 worker VM servers, or whatever you want to call them, for InstaGENI and 10 for EXOGENI. There's 60 cores on InstaGENI and 120 on EXOGENI. There's the network interfaces on each host. For InstaGENI is the 4 1 gigabits. Those are upgradable. And on EXOGENI, they have 2 10 gig. And anyways, I'm not going to read the whole thing, but there's storage, and InstaGENI uses an HP ProCurve, and EXOGENI uses an IBM G8264R. And the important thing here is that the InstaGENI rack uses VLAN-based OpenFlow, and EXOGENI uses port-based OpenFlow. And if you care, there are 2, you can get different power requirements, different kinds of plugs for each rack. Good, and right, so some things to think about from when we tell experimenters that they should use a VM unless they have a good reason to use a bare metal machine, because there's only there's basically 2 bare metal hosts in each rack. In theory, some of them may have 3. Maybe there's like 1 exception. Basically, the bare metal hosts are, they're what we think of them as expensive, if you will. And so having 1 sort of limits the lifetime of your experiments. And we're happier for you to hold on to a VM for a lot longer. And then a lot of people ask about the kinds of virtualization. So EXOGENI uses KVM, and InstaGENI and ProtoGENI uses Zen VMs on also Linux containers. There's sort of a shift happening there from containers to true Zen VMs. Good. there's right. So the speed of the NICs is different, but they're both upgradable. So the EXOGENI ones are you know, faster, although I guess there's fewer of them, and right. So sorry, I was just reminding myself. So the EXOGENI, the interfaces are shared, and whereas on InstaGENI it's possible to get a dedicated interface. And finally, both racks. The important thing is that both racks are supported by the same tools. The sort of common GENI tools, Omni, Portal, FLAC, the INM tools. They both have sort of their testbed specific things that have additional features that are available, but they sort of are both supported by the same core set of tools, and that's sort of by virtue of these common clearinghouse and aggregate APIs. All right, good. Also, if you have questions about the types of racks, the details of the racks, we have somebody from each rack team in the room who can give you like lots and lots of detail about those. All right, so that's what the individual racks look like, and then there's a question of how do you connect them together. Good. So, right. So, GENI doesn't own any networks, right? We work with existing regional and backbone providers in order to connect our racks. And there's sort of 4 ways. If you went to the stitching tutorial yesterday, or not the stitching, the inter-aggregate connectivity tutorial yesterday, they talked a lot about these. So stitching is sort of the GENI way of connecting things. And that involves dynamically configuring VLANs across different domains. There's a tool called Stitcher that's distributed with GCF and Omni that supports this. In addition, EXOGENI has its own intra-EXOGENI stitching, I don't know what to call it, that is sort of works in parallel sort of to stitching, to GENI stitching. And that sort of works not through the AM API, and that's supported by a tool called Flux, which is their sort of testbed specific tool. And so sometimes if you just want a small topology of, right, that's sort of nice to know is there. You can also connect things via OpenFlow. We currently have the mesoscale, although the mesoscale is morphing into a new thing or something. And there's also ALTOS coming online, and some regionals have OpenFlow. For example, there's a few regionals that are listed there. I think there's more. Those are just some examples. We also have these shared VLANs. They're sort of pre-configured VLANs that connect the various racks. And they come in sort of OpenFlow and un-OpenFlow enabled variations. And then in a pinch, connect GRE tunnels between your nodes, but you're doing that over the control interface, which means you're limited in the amount of traffic you can send, and also it has the potential to interfere with experimenter traffic. And so that's sort of something I think is really only sanctioned on the InstaGENI nodes. Yeah. Okay. Is it considered acceptable behavior? Okay, good. Sorry, fine. I would have, sorry. Yeah, I had this. Yeah. Right, right. Right, right. Okay, right. So, the GRE is, there's no tooling, but it's fine as long as you're not, overloading the link. All right, so I'm going to talk a little bit more about stitching. Maybe this is old hat now with the tutorial yesterday and some of the talks this morning, but I'll go over it real quickly. So basically, how does stitching work? There's 2 things, right? There's a lot of manual sort of configuration that's happened in advance. that's sort of done once. We bring up a rack and we put a lot of sort of infrastructure in place to enable stitching. And then there's tools that allow you to make reservations in real time, right? Maybe real time might be strong, but to do it sort of in the amount of time it would take to make a cup of coffee, or on a bad day, have lunch or something like that. But you know, it allows experimenters to get these configured VLANs up sort of on the order of minutes, instead of on the order of weeks, which is what it would be if you had, had to manually go and call up every provider along the way to configure a VLAN. Right, so how does this work? So the rack stitching configuration works by somebody goes in and figures out a path from the rack, between the racks, and or rather from the rack to a national backbone provider, which these days is Internet 2. Until the last month, it also included NLR. So then you find your network provider, and basically, actually here, let's just talk to the picture. So there's a rack, and that rack is on, say, a campus, and somebody on that campus configures VLANs that enable connectivity from the rack to the regional. Then the regional makes available a set of VLANs, usually something like 10 or 20-ish, on the order of 10 or 20 VLANs. And that connects you to the backbone, and then Internet 2, for example, provides a service called ION, which dynamically configures VLANs and does VLAN translation. So if you sort of do this process of getting connectivity from the rack to the backbone provider at every campus and rack, then you get this full topology that you can put together, where you can stitch between multiple places. Then from the experimenter's point of view, there's a lot, or this is sort of the dynamic piece. The experimenter's point of view is actually just steps 1 and 7. And there's a lot that happens behind the scenes. So the experimenter makes a request using an RSpec that looks almost identical, but not quite, to what they would do for the single aggregate case. That goes to the stitching and computation service, which augments that RSpec and makes it, and sort of fluffs it out and fills in some additional information. And then their tool takes that and sends it to each individual aggregate in the correct order, collects manifests, and bundles together sort of this big manifest that contains their stitch topology. And so the experimenter sees something that's a lot like the single resource or single aggregate reservation case, and the tool does like a lot of work for them behind the scenes. And you really should have, this is really the place for Coffee Woman, because she's probably, this takes a few minutes, so she's probably enjoying her cup of coffee while this happens. And yeah, I guess this is one of the things about stitching is there's a lot of, Mark mentioned today that there's, still bugs to be worked out, but it's still, it's still better than spending 6 weeks on the phone with somebody trying to get something to happen, even in its sort of nascent state. All right, and then we are ready to talk about OpenFlow and foam. So that was, I mentioned 4 ways of connecting things together. Stitching is one of them. OpenFlow is the other, and Josh is going to come up, and he's going to tell you all about it. And let me, we're going to do slideshow.
All right. Hello. I'm here to talk about OpenFlow and foam and ways that admins might care about if you're running a rack, running a regional network, any of those kinds of things. I'm going to do a very fast introduction to OpenFlow. There's a lot more to this than I can talk about here, but I'll try to cover some basics and for those not familiar with this sort of stuff. So OpenFlow is, oh, also I talk fast. I'll try to dial it down. If you can't hear or can't make out anything I've said, just wave your arm in the air and say, wait, what? And I'll stop and try to clarify. So, all right. OpenFlow is an API that switches can implement on top of or instead of their usual firmware. There are a bunch of different versions of it from 0.8.9 before in the early days of GENI to 1.0, which is the most widely used on the switches that we have in GENI. 1.4 is the most recent version and isn't supported on any of the hardware we have right now, but is out there. So OpenFlow is a kind of software-defined networking. There are other ways to do SDN, but OpenFlow is one of them and is the popular one in GENI. What that is, so typically the logic of how to forward packets around is defined inside the switch. It's on the firmware on the switch itself. And it might give you some control with access control lists or other things like that, but by and large your configuration and programming options are very limited in traditional switch firmwares. So what OpenFlow does is move that to an external controller that lives outside of the switch, which lets you manipulate the switch's flow table and control how traffic is matched and where it goes once it matches certain rules. Traffic that matches an existing flow rule in the switch gets sent along to its destination at line speed, so this doesn't introduce a performance hit, and you can still get the full throughput out of your switch's nominal bandwidth. And traffic that comes in that the switch doesn't have a flow rule for already, it sends off to the controller to ask what to do with. And this introduces some delays, so you ideally want to minimize this when you're doing your experiments, but it's a thing you can do. So this makes switches not just configurable in the way that an admin typically logs into the switch's command line interface, uses SNMP or something like that, and configures how the switch is set up. It also makes them programmable on the fly in real time as traffic is flowing around. And this makes it easy to do new things and to innovate much more quickly and easily than you could otherwise. You can, as an experimenter, write controllers in any language. There's controllers in Python, in C, in Ruby, all kinds of things, and you can run them on any system like a traditional Linux box or a Solaris machine or whatever else you happen to have and like. And you don't have to have switch-specific firmware to do this. The controller you write, if it speaks 1.0, should be able to do what it does on any switch that also supports the 1.0 protocol. There are sometimes things that switches don't support in the spec, and those are usually ideally documented, but by and large, there's some compatibility here. So the controllers can match traffic and put in flow rules that match traffic at various layers from layer 1, saying if it comes in on this physical port, do something with it, to layer 4, if it's a TCP connection to this particular port, do something with it, and anything in between that pretty much. So there's a lot of flexibility there in terms of matching traffic and deciding what to do based on the characteristics of that traffic. An OpenFlow switch has things called datapaths, which is essentially a virtual switch. I know this is not exactly the right precise definition, but it's a simplification that makes it easy to think about. And each one has a unique identifier that tells you what this, which datapath this is. That is sometimes abbreviated DPID, and I will use that abbreviation throughout the slides and say the word datapath because datapath is bigger on a physical slide. So. There are a couple different types of OpenFlow switches that we see in GENI. One is the VLAN-based hybrid, where the HP switches in the InstaGENI racks are sort of a popular example of this. They've got multiple data paths, and they're based on VLANs. So you configure this by VLAN-17 to be OpenFlow controlled, and now all the traffic that comes in on VLAN-17, instead of being forwarded by the switch's logic, gets controlled by the OpenFlow flow table on the switch or sent off to a controller or whatever. And you can have both OpenFlow and non-OpenFlow VLANs in the same physical switch. So that's that. There are port-based hybrid switches, which are sort of a similar thing where you have some OpenFlow controlled traffic and some non-OpenFlow controlled traffic. But in this case, it's split by port. So you say ports 1, 3, 17, and 24 are OpenFlow controlled, and the rest are controlled by the normal switch's logic. And depending on the switch and its firmware and its implementation of OpenFlow, there might be only one data path that you put the OpenFlow ports on, or there might be multiple data paths, and you can say, have these 3 ports on this data path and these 5 ports on this other data path, and send those to different controllers. So it just depends on the switch and what they've implemented. There's the idea of a pure OpenFlow switch. There's only one data path. The switch just is an OpenFlow data path, and there is no traditional switch configuration at all. There are no access control lists. There are no VLANs. Everything the switch does, it does OpenFlow with. So the Pica 8s that you may have seen around are an example of those. And finally, there are virtual switches like OVS and its friends, where it's a software switch running on a computer of some kind. So here are some places where OpenFlow is in GENI. You've seen this picture, 100 times or more at this conference alone, and probably before then too. But in particular, the takeaway for this particular talk is there is an OpenFlow-enabled hardware switch at each GENI rack, both Insta and EXOGENI, and also the new Dell and Cisco racks also will have OpenFlow hardware switches. I'm not as sure about Cisco, but I think they're going to. And in the backbone and regional networks also have hardware OpenFlow switches. So that's where those are in GENI. This is a real quick intro to what OpenFlow is and does. If you would like to learn more about OpenFlow, either from an admin or from an experimenter perspective, to know sort of what experimenters that you support might be doing. Yeah. Mm-hmm. The ones in the racks are the ones, yeah, I mean, the ones in the regionals and backbones are to some extent. The AL2S ones are not, and the ones in ION are not, but like the five, ah. Although if you've got in the EXOGENI racks, if Orca is allocating a VLAN, is it, or not, it's not a VLAN, because, well, is it a VLAN, is it, what's the flow path from the switch to the experimenter? Does it actually go through Flowvisor in that case, or no? Okay, 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 okay. Yeah. Okay, that makes sense, and that's actually a difference between the way EXOGENI can do this and InstaGENI, where there is the shared VLAN that the hardware OpenFlow network uses points to Flowvisor and is controlled by foam, which we'll talk about more in a sec, and is one way to get OpenFlow control in each of the racks, but they both have the shared VLAN that points to the foam-controlled Flowvisor. You can also, as Victor was saying, get directly from Orca an OpenFlow VLAN essentially, and likewise from ProtoGENI, you can in theory get an OpenFlow controlled VLAN from ProtoGENI. But in that case, I think what it does is it provisions the VLAN, makes it OpenFlow controlled, and points it directly to your control room. There's no Flowvisor in the way, which is nice because there's no Flowvisor in the way, but again problematic because it means nothing to stop you from doing various horrible things to the switch. So it's an interesting trade-off, as all of GENI is. So good question though. Yeah, yeah, and the state of all this stuff is evolving somewhat. I'm not actually sure offhand. Is John Durig in the room? Where'd he go? Yeah. Hey, do you know what's up with the OpenFlow controlled VLANs and ProtoGENI on the InstaGENI racks? Is that live now, or is that a new coming soon thing? I don't remember. Yeah, yeah, yeah. Okay, right. I wasn't sure if that feature was actually live yet or not, but yeah. Okay, okay, cool. All right, that help. All right. So more training. Indiana University runs an OpenFlow class specifically for network admins. Unlike many of the tutorials here at GEC, which are more experimenter focused, this is really for network admins who want to learn more about OpenFlow. And it's not, I think it's not GENI specific either. It's just a general thing they do. They've offered this at meetings like NANOG in the past, and will probably offer it in the future. This information was current as of January. I forgot to double check this beforehand, but Stephen Wallace at IU was the guy who was coordinating this sort of thing, and you could talk to him for more information. They also have the slides from the class online as a Google Doc, and this short URL will take you to the full thing. Also, these slides are on the wiki, so you can get for the page for this session off the GEC19 agenda, so there's that. And then GEC, of course, has tutorials that are not necessarily admin specific, but if you want some insight into what experimenters at your site are learning and doing and seeing, you can also visit those to learn more. Or if you also have an experimenter hat you'd like to wear sometimes. All right, so that's OpenFlow in general. Let's talk about Foam in particular. Foam is an aggregate manager for OpenFlow resources, so it's a way for experimenters to get stuff via the GENI AM API. Much like ProtoGENI is for the InstaGENI racks and Orca is for the EXOGENI racks. It uses Flowvisor to allocate OpenFlow resources, which are the flow space on the switch. And so this is in the same kind of way that you might use ProtoGENI to get a Zen VM or Orca to get an OpenStack VM. In the Foam world, Foam is the aggregate manager, Flowvisor is the thing that allocates stuff, and the OpenFlow resources are the stuff. So there's that. We have a URL with some introductory information for new Foam admins. If you have a rack or our regional network and are either have been or in the process of getting set up, we should have sent you this link. If we did not, we are very sorry. But here it is here. That link has all the information from this part of the presentation. It's also got links and more details and links to other resources and good stuff like that. And definitely if you're a new Foam admin, either at a rack or a regional or just for fun, for your own purposes, it's a good place to start and learn a little more. And another good resource is the GPO infra list. This is the infrastructure group at BBN in the GPO. And it's a fine place to ask anything, comments, questions, feedback, complaints, threats. We like it all. So the basic architecture of Foam, how this network is all working. As we said before, a physical switch has one or more data paths, and each of those is essentially a virtual switch. Each of those has a DPID. So Flowvisor then takes that and slices traffic into flow spaces. From the switch's point of view, its controller is Flowvisor, and it then slices that out into different flow spaces and sends each of those to a different controller for an experimenter. So each experimenter has their own, and Flowvisor provides some separation between them. It is in theory both as if the switch has a question, gets unknown traffic and needs to ask a controller, it says to Flowvisor, hey, what do I do about this? And Flowvisor looks at its rules and says, oh, I need to ask Sarah's controller about this, or oh no wait, I need to ask Russ's controller about this. So it's doing some sort of filtering on that side of things. And then also when Sarah's controller sends back a flow mod or some other thing and says, yeah, send that controller out this port, Flowvisor on the other side says, great, is that port actually part of your slice, or is that part of Russ's slice and you shouldn't be sending traffic there? So it's trying to do some amount of separation of the flow space, and it's pretty good at that. The performance limiting stuff is a little less mature in some ways. So in any case, Flowvisor is slicing your traffic, and it's completely controlled on the racks and in the regionals typically by Foam. It doesn't necessarily have to be, but this is certainly convenient. It means you don't have to worry about other things showing up in Flowvisor that Foam doesn't know about. You can... Oh. That's true. EXOGENI is an unusual case here, and yes, it's delightful. So Foam and Flowvisor can run on either a single host or a bare computer or on two. There's some advantages to having them on two. It means that if you need to do something for some reason that requires you to reboot the Foam server, you don't take down Flowvisor also. This doesn't come up too often, but it's something to think about if you're deploying your own thing from scratch. EXOGENI happens to have them each on separate VMs on the control node. EXOGENI runs them both on the head node. So either way works, and we often put them both on one machine for simplicity's sake. The resource requirements for Foam are very light. It's an Nginx server and a CGI process, and that's it. So there's not much going on there. Here's a diagram of this architecture. Excuse me. So some things to note here. Here at the bottom are a couple of switches that are talking to Flowvisor, which to the switches looks like a controller. And then on the other hand, Flowvisor talks to the experimenter's controllers, and to those controllers, Flowvisor looks like a switch. So it's acting as a proxy and sort of being each thing to each half of the things it talks to. Excuse me. So the traffic that comes into the switch, then if you see if traffic comes into the switch and there are existing flow rules, it just flows right through and things happen at wire speed. If traffic comes in and doesn't know what to do, it sends it to Flowvisor. It figures out what controller to send it to, all that kind of stuff. Foam in that yellow box over on the other side there then talks to Flowvisor via one of Flowvisor's own APIs, the Flowvisor XML RPC API, to configure Flowvisor and say, here's a new slice someone created, here's the traffic that you should match for it, here's the things you should allow them to do. Now you have something new to slice traffic based on. And then experimenters from their desktops or laptops talk to Foam via the GENI AM API. So an experimenter creates a sliver at Foam. Foam creates a Flowvisor slice at Flowvisor, and it then does stuff with traffic once traffic starts flowing. And one key takeaway from this is that if Flowvisor is down or if a controller is down, traffic won't flow. If Foam is down, Foam is not actually in the path of live traffic flowing. Foam is only used to configure Flowvisor. And so a Foam outage does not actually cause a data plane outage of traffic. It just interferes with your ability to make new things or manipulate your existing things. Yeah? That's coming up. Stay tuned. Yes. Well, it is significant, though, because in fact, Alice might be an experimenter at Clemson, and Bob might be an experimenter in Alaska, and this might be a switch in Florida, and so these things can be all different places, and that can have some implications for performance and things like that too. When the Flowvisor talks to your controller, it's talking via TCP, and that has latency issues and so on and so forth. So another good reason to have your flows in the switch matching traffic at line rate and not be sending everything off to the controller. So. Yep. But so if an experimenter, as an admin, if an experimenter asks you, where do I run my controller? The short answer is really anywhere you want. And it could be on their desktop, on a node in a rack, on a node in a different rack. It could be, more or less anywhere that has an IP address that you can then tell Foam and Flowvisor how to find you. So, any other questions about this? All right. Auto approval, Victor mentioned. In most other GENI aggregates, requests are auto-approved by default if the resources exist. If you ask for 1,000 VMs, you probably won't get that. But if you ask for a VM and the resource is available, the aggregate will give you the resource. And that's simple because it knows how many VMs it can allocate. It knows how many bare metal PCs it has, that kind of things. And once it allocates one of them to somebody, that one is allocated to that person, and there is no sharing of these resources once the resources it gives out are given out. They're now controlled by that person, and that's it. OpenFlow is more complicated because flow spaces can overlap. And so Alice, for example, can request a 16-bit IP subnet and get that. And then what happens if Bob comes along and says, well, I'd like an 8-bit IP subnet that includes Alice's subnet, or a 24-bit subnet that is included inside of Alice's subnet. It's not immediately obvious that these are not obviously the same thing, but they are overlapping things, and you sort of can't have each of those people having some of it. So this used to require manual administrator approval back in the early days of Foam and its nameless predecessor. The admin had to approve by hand every request and review them by hand too, and say, let's see, Bob asked for a 10008. Does that overlap with anything? Let me look at my existing slices and go through by hand and see if I see anything that looks like it would clash with this. That was tedious, unpleasant, and error prone. So nowadays, modern versions of Foam have an analysis engine that looks at the flow space requested, compares it to existing slivers that have existing flow space, and if there isn't any overlap, it gets approved automatically. If there is overlap, then something else happens. The request gets marked as pending by Foam instead of approved, and this will show up in sliver status if an experimenter looks for it, or if you look in the Foam control program. You as an admin will get email from a nightly cron job about pending slivers, so they don't just languish there forever. And this is a thing you should actually do something about. More about that in a sec. Usually, the experimenter will need to delete their sliver and try again. Usually this comes up because someone requested something that overlapped with somebody else's stuff. Maybe they had a typo, maybe they, who knows, but most of the time in our experience, the experimenter requested something they really can't actually have at this moment anyway, and will need to delete it and try again. Or possibly they've requested something that they should actually have, and someone else got it first who shouldn't have it, and so you have to ask that person to delete it and try again. But that's somewhat more uncommon. These messages and don't know what to do or aren't sure what to do or just want to talk about them because they're interesting and fun to discuss, GPO infra, always a good place to ask questions and send your doubts and so on. Yes? Say again? It's not based on VLANs necessarily. So in particular, in the hardware mesoscale currently today, there's a single shared VLAN, and the flow space is actually sliced by other criteria like ether type or IP subnet or MAC address or something like that. And so my example sort of on this previous slide about people getting IP subnets, where's the previous slide? There's the previous slide. Isn't completely fictitious. The way people use that network right now is to get a slice by IP, and so you could be requesting a subnet that overlaps something someone else has. In the future world of more pure sliced by VLAN hardware OpenFlow networks, this will be less of a problem, and it's the future is murky. Whether foam will be allocating those things, or if in the way that ProtoGENI currently allocates VMs on the InstaGENI racks, maybe it'll be a different aggregate manager at that point, and there won't be any of this Flowvisor foam stuff. We don't know for sure what the future will hold in that respect. So. Right. Yeah, I don't have, unfortunately, a good map of this on a slide, but what's going on essentially is in that shared mesoscale VLAN, it's all carried on the single VLAN in I2 and through the regionals and everywhere. That hardware network only has the one VLAN, and so you can't get your own VLAN on the network right now, and that's a serious limitation for experimenters, and why we're trying to create other options there. Russ. Some. Good. Some, and I don't, unfortunately, I have an example of this on my slide either, but yes, in sort of. Let me keep talking, and if I forget this, remind me, because there's a point where this would be good to interject, but yeah, remind me again in 2 minutes if I have forgotten this. All right. So, email from foam. Foam always sends mail right away when experimenters act on slivers. They create and delete and renew and otherwise manipulate their slivers, both to you, the admin, and also email to the experimenter. It sends email when slivers get approved, and it sends mail when slivers get disabled by the admin, a thing you can do. This is useful. The disabling is useful if you need if someone's doing something weird or bad or otherwise hinky, you can disable the sliver in foam, which will take it out of the Flowvisor without deleting the entire thing. And so if you then want to put it back later, you can do that without having to have them recreate the entire thing. It does not send mail when a sliver is created but not auto-approved, except for that nightly cron job. And so to your question about the experimenters, a savvy experimenter will see they got a sliver created message and did not get a sliver approved message and scratch their head and wonder, what is up with that? Or they'll look at their controller and say, I thought I created a foam sliver, why am I not seeing this data path connected to me, or something like that. And they can then do a sliver status, and in the sliver status from foam is a foam penned reason, which tries to explain what happened, and it does the best it can to try to say flowspace overlap with the subnet overlap with something else, or something like that. But it's trying to express things generally that maybe there may be something more subtle going on. The experimenter can't see exactly what they clashed with necessarily. So the fact that Bob had 10.0.0.8 isn't going to be expressed to Alice when she creates a sliver, but it will say overlaps with an existing sliver of some kind. So the admin can see that stuff, but the experimenter typically can't. Ah. That could in theory, but it does not. Good question, though. Yeah, the other way it could exit pending state is if the experimenter deletes it, but that's sort of yeah. Right. Right. It doesn't ever recheck. So yeah. Yep. So the other kind of email foam sends is these two cron jobs. It sends mail when slivers expire, as every sliver in GENI has an expiration date. Every hour, every 6 hours. 6 hours? Yeah, probably. It checks to see if there are any slivers in foam that have whose expiration dates are at this point in the past, and deletes them and sends mail saying, sorry, your sliver expired. It actually also sends mail when slivers are going to expire. I didn't put on the slide here, but this is useful for experimenters to sort of get a warning of your thing is going away in about a week and your thing is going away in about a day, to give them some time to say, wait, that's bad, and renew it. And it sends mail when there are pending slivers that need approval. This is a nightly job that runs at midnight or so by default, depending on your time zone and other things like that. And that's the important foam email. So I sort of alluded to this before. Those pending slivers require some kind of action. If no one does anything, nothing good will happen here. So usually the experimenter will want to delete it and try again, fixing whatever they didn't work the first time. Or the existing sliver, as I said, may have reserved things they weren't supposed to. Excuse me. A savvy experimenter will know something's wrong. They'll see they didn't get the approved message. They'll see the thing isn't connected to their controller, and they may in fact just go in and delete the sliver by themselves before foam even notices and does this, this nightly cron thing. But a naive experimenter may not know what's wrong. Someone who is doing a tutorial or following an instruction from an online thing and is new to OpenFlow may not know exactly where to look to see what's happened here. So it's important to keep an eye out for this cron mail if you're a foam admin, and it looks like this in this box. So there is that. Less important foam email is sort of the routine messages that don't need you to do anything. This is just foam notifying you that things are happening. And so here's an example of that in this yellow box, saying that someone created a foam sliver, and here's its ID and stuff. And it mentions at the bottom, if it wasn't automatically approved, go check and see what's in the queue. The wiki has more info about how to actually go in and approve things or disable things. It has also some information here about what to do if you do not like the email you are getting. You can control whether foam sends you mail when things get created and deleted and so on. If you don't want that at all, you can also sort of safely proc mail these or read them in great detail as you like. But these links have more info about how to configure and control that kind of stuff. So some closing thoughts. There's a lot of information about foam configuration in general at the URL there, and some guidelines about how foam isn't a completely GENI-specific product, and so we talk about how we think you ought to configure it in GENI to be nice to other GENI people. Typically in racks, the rack admin teams will already have done this for you. You can review what they've done. You can see if you don't like it. If you find something you think you want to change on a rack especially, it is probably good to check with the rack admin team or the GPO to make sure that what you think you want to change will actually do what you think it will do, and give you the effect you want, because it's not always as intuitive as perhaps it could be. For software upgrades, the GPO keeps track of sort of new versions of foam and Flowvisor, and test them. And when something comes out that's new, we test it, we like it, we send mail to the response team mailing list when it's time to upgrade things. And for racks, the rack teams currently handle all the upgrades. So I will usually explicitly say in these messages, if you have a rack and don't do this, the rack teams will take care of it. But that's typically true, even if I don't say it. For Flowvisor itself, you shouldn't generally need to be poking at Flowvisor under the hood. But if something is going wrong for debugging a problem, things like that, there is a wiki page with some useful Flowvisor commands, and you can and if you're just curious, you can create a sliver, see what foam does, look at foam and see what state it's in, and then go look at Flowvisor and see what state it's in. So you can sort of see what foam has done to Flowvisor as a result of creating or deleting or approving or whatevering that sliver. Upgrade procedures are the same. The rack teams will take care of it by and large on racks, and the GPO tests things and sends out mail about it. As Heidi mentioned in the plenary, the odds of upgrading Flowvisor ever again, we hope, are slim, but you never know. As always, when in doubt, GPO info, a fine place to send all of your thoughts about foam, rack administration, any of that kind of network admin, system admin kinds of stuff. And I think that's it. That seems to be it. And now, back to Sarah. Is there a back to Sarah? Are you doing the email? Yeah, okay, good. I thought so. Okay, yeah. I suddenly wasn't sure.
Yeah, right, right. So this used to be a really, really big deal, and now like auto approval has like all but eliminated, I think. Yeah. Okay. All right, and I'm gonna be as quick as possible. Okay. So so we talked about the racks and how they're connected to each other, but there's this other aspect of operations, which is sort of meta operations. Because GENI is a federation, there's people at various places, rack admins and stuff, who sort of own and operate their own devices, own equipment, and in conjunction with the rack teams, and so. But there's still this need for, in terms of debugging and tracking what's going on in the world, to have sort of this layer above that, and we call that meta operations. And so the idea there is to be able, if there's a problem or some major event plan, that you can sort of keep track of what's happening. So GENI meta operations basically has a calendar, and they keep track of unexpected outages of any kind, and they also keep track of notifications about resource reservations, for example, tutorials or classroom use or large experiments. And in addition, they do this thing called emergency stop, which I think, I think I have a slide a little bit more about later, so I won't talk about that right now. Okay, but there's this calendar which is really helpful to tell what's sort of happening in GENI land. Okay, so is monitoring. There's going to be talk about that, I believe, this afternoon in the operations session, I assume. And so there is monitoring in place. I don't have a lot to say about it right now because it's changing quickly. Occasionally, somebody's paying attention. Occasionally, you might get email from somebody, sort of a one-off email saying, hey, we can't ping your rack, or the AM API isn't responding to calls, that kind of thing. So that is out there. GMOC sends notifications out on some various mailing lists for sort of three kinds of things. One of them is sort of proper outages, hopefully maintenances, but we've had an incredible amount of power outages on the East Coast this year. And in addition, they do things for large events, classes, tutorials, demos, and for potentially disruptive experiments. Right, so the calendar is linked there, and here's, good, I just want to talk about these just a little smidge. So if somebody's doing something large and they need a lot of resources, you send an email to GMOC and say, I want to reserve the following things. And so you might see one of these, and so what would you do as somebody at a campus? Is there something happening that would affect this? Then you would let GMOC know, and they can coordinate. Conflicts are really, really rare. Most of the things that would be a problem, the rack teams would take care of. But if there's something like, the power is going to go out tomorrow for 12 hours, that's the kind of thing you might let GMOC know about so that they can deconflict it. So there's emails that come out. Currently, they're a little cryptic, and so I just want to walk through them really quickly because that's it's a wall of text. So here's an example of an email for our Spring Train the TA tutorials. It says what resources, what tools we're using, what resources we're using, sort of all of that. And basically, if you're a rack admin or at a campus and your location isn't listed, then you can stop reading. Then it says, the start and end times. There's a description, what is expected to happen, and there's this these little numbers here, which are the ticket number for the calendar. And so if you send an email about this, you should include that ticket number so that GMOC knows what's going on. And there's a little website so you can find the calendar and other things. Okay, So the other kind of email I want to talk about a little bit is sort of these potentially disruptive experiments. So basically, occasionally we get an experimenter who wants to do something that could interfere with other experiments, or is, I guess the example here is reserving a large amount of bandwidth on a link, which is sort of, maybe that's not quite disruptive, but we've seen this a few times recently where somebody wanted to reserve 700 megabits of a 1 gig link. That kind of thing. We'll ask them to do a notification, and we'll sort of schedule that event so that it doesn't interfere with other things. Right, and so GMOC sends notifications so that sort of other people in the community know what's happening if they see something unusual. And basically if there's something unexpected happens and there's weird behavior during one of these, contact GMOC and they'll ask people to stop. Good, so this email looks pretty similar. There's the name of the event, again, who's affected, again, if it doesn't include you, you can stop. Duration, description, the same sort of ticket number, and yeah, so that's pretty similar to the other one. Right, and I also mentioned this sort of emergency stop process, right? So we have, GMOC has this well-defined process. This is an eye chart. But the point is there's 24/7 staffing done by the folks at Indiana who keep track of things, and if something goes wrong, they can make it stop. And so so this is pretty important, right? There's sort of two things that can happen, right? Somebody can have taken over resources or done something bad, actively bad, or there can be a misconfiguration or an experiment that just sort of goes wrong, right? We had an issue a couple months, last month or two, where somebody was sending too much traffic over the control interface, and it was interfering with the operation of the system, and so we contacted them and had them stop, and Eldar who runs the GMOC was keeping close tabs on that in case he needed to do something more serious, right? Right, so GMOC tries to keep track of things so they know what's happening and notice if something goes wrong, and then they have this mechanism to sort of quarantine traffic in a pinch. And good, and they work with, so there's GMOC itself, they work with aggregate operators, they work with sort of various regionals and backbone providers. In particular, it's the same folks who run the Internet 2 NOC, and they also work with the GENI legal law enforcement representative who makes decisions about sort of the point of contact if something goes wrong, and they have some contact information in a calendar. Okay, and then real quick, there's a few tools for rack administration. We're not gonna do a tutorial for them, but we wanted you to know that they're out there in case you see one, so that you can sort of find out more. Okay, so the main thing is that currently rack teams do a lot of the actual rack administration. There's tools for managing the racks. Those tools are specific to your type. And if you don't already have one, you can request an account from your rack team for your appropriate rack. Okay, so I'm gonna start with InstaGENI again. So InstaGENI sends administrative email when an experimenter acts on a sliver, create, renew, delete. There's some routine events, and also when something really serious goes wrong. And there's a wiki page that has details about the individual emails. So here is a typical InstaGENI administrative email. So we have note who did something, in this case Josh. We note the time, information about the slice, its URN and UUID and things like that. And there's this log URL, which is really, really handy, where you can go and you can find sort of the error messages and things like that, sort of like a multi-page thing saying what happened. So that's a good thing to go check out if something's gone wrong, and it's also good to include in the email if you need to report an issue. All right, then InstaGENI has this thing called red dot mode. If you go onto the individual rack, there's this the web interface, and allows administrators, and only administrators, to see a little bit of information. So there's this green dot that you'll see if you're an admin, and if you click on the green dot, you have to be an administrator, you can tell. You'll be listed as an administrator if you are, and then you can click on the green dot, which puts you in red dot mode, and basically on the various pages there's additional information that shows up. All right, so EXOGENI has a similar set of tools, but they're sort of different. EXOGENI doesn't send administrative email, I don't believe. Yeah, none at all in the entire, yeah, no EXOGENI email. They have three things. They have pquad, which is a command line tool for sort of accessing and managing your rack. There's a monitoring web page, and there's a lot of wiki documentation, and there's links on here. So pquad is just this little command line tool. You log in to the head node of your rack. You just run pquad, and you can query information, you know, how many VMs are on my local thing. Like here, there's 19 reservations, for example. Yeah, sure. Ah. I'm sorry. Yeah. I see. I see. Sorry. I stand corrected. Right. Okay, and then there's some admin, there's some monitoring web pages. So they're basically running Nagios, and you can see, you know, status of racks, various interfaces, and things like that. And I think you log in with your EXOGENI wiki account. So if you have one of those, then you can just log in and check out the monitoring on your rack, which is pretty cool. Okay, and then I think this is the last section, basically how to get help. How are we doing? Good. Give me 2 minutes and I'll finish up here. So how to get help. Basically, I mean, you guys probably know how to report a bug, but you know, gather as much information as you can. If you're running something, you're reserving something, mention the type of account you're using or the tool. If you see something that's going wrong and you have information about slice names or URNs, aggregates that are being used, which is probably yourself, any error messages, that kind, as much of that information that is relevant, please include that. Screenshots are helpful, that kind of thing. Josh always repeats this mantra, which I'm sure is about, you know, what did I expect to happen? What did I see? And what did I do? And what did I see? Or something like that. Anyways. Yeah, clearly. Anyways, so we have a bunch of mailing lists. GENI users is more of an experimenter-focused thing, but basically anybody's welcome to join and ask questions. This has actually become really, really useful for debugging things like stitching, where there's these, you know, I tried to stitch between this place, and there's turned out there's 4 aggregates involved, and there's a stitching service, and there's a tool, and that's, where do you even begin to start asking that question? So GENI users is the place for that. Response team has somebody from every site in GENI, and that's really good. You're probably already on it if you're a rack admin. Help@geni.net is sort of a catch-all. For technical questions, I would go to GENI users first, but if in doubt, you can always email help@geni.net, and we will make sure your email goes to the right place. And you can send email to GMOC via that email address. And then there's lots of other sort of topical mailing lists. There's specific ones for the different racks, and then you can email the infrastructure group in the GPO. And then there's lots and lots of wiki pages. There's an IRC chat channel. There's lots and lots of mailing lists. There's many, many mailing lists. But these are sort of some of the top things. And then that's it. I think it's lunchtime. But if folks have questions, we'd be happy to chat and lunch or something like that. Oh, and there's a survey, because apparently this is a tutorial, because it kind of is. Yeah. Sorry. Yeah, it's the same thing. So, yeah, actually. So, do you want a survey? So, anybody have questions? You're welcome. Thank you. Yep. Yeah, they're on the they should be on the wiki page. Yeah, yeah. So. Are we good? All right. Questions? Oh, I don't know. Or did we ask all our questions during the middle? Maybe we did. Maybe that's good. Okay, and then we can eat. Oh, yeah, yeah.